Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at Form 1 chemistry. And our focus today will be water and hydrogen. We are going to be further discussing on some of other properties of hydrogen gas. We introduced the reducing property of hydrogen gas in our previous lesson. You can go back and check on that. And today we are going to be looking more at other properties of hydrogen gas in terms of its reducing property. And then also we are going to work on a few questions. So one of the compounds we are also going to discuss apart from our copper 2 oxide that we discussed in the previous lesson is lead 2 oxide. Lead 2 oxide can also be reduced by hydrogen. So the procedure is that the dry hydrogen is passed through the combustion tube, as you can see in the image, for some time. So we are passing it before starting heating of the lead 2 oxide. The reason why we do this is to drive out any air that might be inside the combustion tube, because we do not want the final metal that we get to be reoxidized. And then also we also drive out that air because we do not want the hydrogen gas to mix with that air. You can see we are burning the excess hydrogen at region Z. So if we had some air in the combustion tube, that air is going to mix with hydrogen, and in turn, when it's ignited at region Z, it's going to explode. So we do not want that to happen. Then the gas is usually passed continuously, and then it's heated at the jet. The reason why we heat the gas at the jet is because we do not want the excess gas to go to the atmosphere. And then the apparatus are allowed to cool as the hydrogen gas is still being passed through the apparatus. The reason why we do this is because we do not want a re-entry of any oxygen. So if we stop passing this hydrogen gas, some oxygen is going to enter and is going to reoxidize our metal, and we're not going to get our final product that we intend to get. So that is the reason why the hydrogen gas is passed, even as we allow the apparatus to cool. We talked about the hydrogen gas being burnt at region Z. We do not want it to go into the atmosphere because we know that hydrogen, when it reacts with oxygen, and if you ignite it, it's going to be very explosive. So the ignition part must be there. So let's look at some of the observation. So one of the things we notice is the color change of the metal. So what is the color change? We started with a gray solid of a yellow solid of lead 2 oxide, and when it reacts with hydrogen, it turns to red first, and then after some time it forms a gray solid. So you can see we are moving in three observations. This is similar to also when we were reacting the lead also with oxygen. So it moves from yellow, red, and then gray. So this tells us that lead oxide is yellow when cold, and then red when hot. So other books will say orange, and then it turns gray when it's just a solid, when it's unreacted. So also you'll notice some colorless liquid on the cooler parts of the combustion tube. And we know this colorless liquid is formed because of the water that is being formed. So when we explain the reason why the yellow solid turns to red and then gray, is because the hot red, you see it is hot red, lead 2 oxide is usually reduced by hydrogen gas into a gray lead metal, while the hydrogen gas itself is oxidized to water. That is the reason why we have this colorless liquid on the cooler parts. So the colorless liquid can be confirmed to be water by using ether anhydrous copper 2 sulfate, which is white in color. and when it is used, it forms a blue hydrated copper 2 oxide. If anhydrous cobalt 2 chloride is used, you can see the anhydrous cobalt 2 chloride paper, it turns from blue to pink. So those are some of the observations for this reaction. So next you look at some of the equations for the reaction. So we said lead 2 oxide will react with hydrogen to form lead and water. This is the word equation, and then this is the chemical equation. So you notice the change in color once more. It's yellow when cold and red when hot. I said other books also note orange when hot. So it's still acceptable. And then the final metal is gray in solid. And then at the jet, we said also the excess hydrogen is burnt at the jet. We do not want this to go to the atmosphere because we said that if it mixes with air, it's going to explode. So this is the equation for the reaction. This is the chemical equation. So it is hydrogen reacts with oxygen gas to form steam, which can cool down to form the liquid water. So that brings us to the end. So the conclusion is hydrogen is a reducing agent. So if you were to write that equation, it would be lead 2 oxide, just like we did in the previous class. So lead 2 oxide will react with the hydrogen gas to form lead metal and water. So you see the lead 2 oxide is undergoing a reduction process, and the hydrogen gas is undergoing oxidation. So this tells us the lead 2 oxide is the one that is donating oxygen, so it is the oxidizing agent. And the hydrogen gas is the reducing agent. So that's what we make on this subtopic. Let's do one more question in regards to what we have discussed. So study the reactions below and answer the questions that follows. So we can see our hydrogen gas reacts with lead 2 oxide to form lead and water. We have process A and we have process B. So define oxidation and reduction. So oxidation is a gain of oxygen, while reduction is the loss of oxygen. And then the next question is identify process labeled A and process labeled B. So process labeled A, we see lead 2 oxide moves from an oxide to so if we look at process A, we are moving from lead 2 oxide to lead. So you can see our lead 2 oxide is changing to lead. We are losing an oxygen. So we call this process reduction. While hydrogen gas is changing to water. So we are adding an oxygen in hydrogen gas. So we are going to call this oxidation. So those are the processes A and processes B. And then question C asks identify the oxidizing agent and the reducing agent. So we said that the substance that is undergoing reduction, or the one that is giving away the oxygen, is the oxidizing agent. And the substance that is taking away the oxygen, we called it the reducing agent. So in this case, the hydrogen is the reducing agent, the 2 oxide is the oxidizing agent. So state the observations made in the above reaction. So there are some two observations that you note in this reaction. First, we are going to note the color of lead 2 oxide. So lead 2 oxide will turn from yellow to red and then to gray. And then another observation is colorless liquid. Liquid is going to be formed on the cooler parts of the apparatus. So that brings us to the end of this reducing property of hydrogen. And also, like, because we have also been looking at other compounds like copper 2 oxide. So when we come in the next lesson, we're going to finish up on the properties of hydrogen, discuss the applications, and then conclude this topic. So see you in the next lesson.